The silent fabric of the cosmos has once again revealed something that challenges the boundaries of human understanding. Far beyond the familiar structure of galaxies and glowing nebulae, a discovery has emerged that feels almost impossible, something that forces scientists to rethink what black holes can truly be. The James Webb Space Telescope, humanity's most powerful eye into deep space, has detected a phenomenon that defies long-standing expectations about the behavior of supermassive black holes. At the heart of a distant galaxy, billions of light-years away, Webb observed not a stationary cosmic giant consuming its surroundings, but something far more dramatic. A supermassive black hole in motion, escaping its own galaxy. This is not a gentle drift. It is not a slow orbital shift. It is a high-velocity ejection, a cosmic exile unfolding on a scale that dwarfs imagination. The object is moving at nearly 4 million miles per hour, fast enough that it could cross the distance between Earth and the Moon in minutes if scaled locally. In cosmic terms, it is a runaway giant, an engine of gravity hurled into intergalactic space. Across the world, astronomers paused in disbelief. For decades, black holes have been understood as the ultimate anchors of galaxies, immovable centers where gravity dominates everything around them. Stars orbit them. Gas collapses into them. Entire galactic structures depend on their presence. Yet here was one breaking free. It is as if the universe itself has rewritten one of its own rules. The James Webb Space Telescope, designed to observe the earliest light in existence, captures photons that have traveled across billions of years. Each observation is not just an image, it is a reconstruction of cosmic history. And this particular observation revealed something no model had predicted. A black hole not as an endpoint, but as a traveler. As researchers analyzed the data, a more astonishing detail emerged. The object is not merely moving through empty space, it is interacting with it in a profoundly energetic way. As it tears through vast clouds of interstellar gas, its immense gravitational and kinetic influence compresses matter in its wake. This compression triggers shockwaves that ripple outward, collapsing hydrogen clouds into dense regions where new stars ignite. Instead of leaving destruction behind, it is carving a trail of creation. Stretching behind the runaway black hole is a luminous structure spanning nearly 200,000 light-years. A glowing arc of newly formed stars, gas filaments, and energized plasma. It resembles a cosmic river of light flowing through darkness. A paradox has emerged at the heart of this discovery. The universe's most feared object may also be one of its most unexpected creators. To understand this, scientists examined simulations and compared observations from multiple instruments. Independent verification came through cross-analysis with other space observatories, strengthening the conclusion that this is not an anomaly or imaging artifact. It is a real astrophysical event. As the black hole moves through dense regions of gas, shock fronts propagate outward like invisible waves. These waves compress interstellar material just enough to trigger gravitational collapse. In those collapsing regions, new stars are born, hot, massive, and short-lived. Each of those stars will eventually explode, seeding space with heavier elements. Iron, carbon, oxygen, building blocks of planets, atmospheres, and possibly life itself. What begins as violent motion becomes a chain reaction of creation. Astronomers describe this as a reversal of expectation. Black holes were once defined by consumption, by their ability to trap light and erase structure. But this phenomenon suggests they may also act as cosmic sculptors under certain extreme conditions. Not just destroyers of matter, but shapers of galaxies. Not just endpoints of collapse, but catalysts of renewal. As the runaway black hole continues its journey, it is effectively reshaping the region it passes through. Its trajectory is not random. It is carving structure into the intergalactic medium, leaving behind a luminous signature that may persist for millions of years. This raises deeper questions. How does a black hole acquire such velocity? The leading theory involves gravitational recoil, a violent consequence of black hole mergers. When two supermassive black holes collide, the gravitational waves they emit can be uneven. That imbalance can produce a powerful kick, launching the merged object out of its host galaxy. A collision so extreme that it literally ejects gravity itself from its origin. If confirmed, this means galaxies may sometimes lose their central engines entirely, becoming structurally unstable, drifting into new evolutionary paths without the influence of a central black hole. But this is only part of the story unfolding in Webb's observations. In a separate region of deep space, another extraordinary system has been studied, a luminous galaxy merger known as ARP 220. What appears at first to be a single object is actually the aftermath of a colossal collision between two spiral galaxies. Hundreds of millions of years ago, these galaxies began a slow gravitational dance, spiraling toward each other until they finally collided in a catastrophic merger. The result is one of the most intense star-forming environments known in the nearby universe. Within a region only a fraction of the Milky Way's size, hundreds of star clusters are packed tightly together, forming at extraordinary rates. The density of gas and dust is so extreme that star formation occurs almost continuously, like a furnace that refuses to cool. Radio and infrared observations reveal hundreds of supernova remnants, evidence of massive stars that lived fast and died young. Each explosion injects energy and heavy elements back into the surrounding environment, enriching it for future generations of stars. This is not a static galaxy. It is a system in transformation. Webb's infrared vision penetrates the dense dust clouds that obscure visible light, revealing delicate tidal structures stretching outward from the galactic core. These elongated streams of stars and gas are the remnants of gravitational forces tearing through both original galaxies. They are scars of a cosmic collision still unfolding. At the heart of ARP 220, glowing filaments reveal regions rich in complex organic molecules. These chemical signatures suggest that even in such extreme environments, the ingredients of life can form and persist. Dust grains glow like embers in deep space, while colder regions shimmer with newborn stars emerging from collapsing clouds. The entire system behaves like a cycle, destruction feeding creation, chaos giving rise to structure. Across both discoveries, the runaway black hole and the merging galaxy, a consistent theme emerges. The universe is not stable. It is not static. It is in constant motion, shaped by forces that transform everything they touch. Black holes can generate structure instead of only consuming it. Galaxy collisions can give rise to entirely new stellar systems. Even the most violent events in the cosmos contribute to long-term creation. Each discovery adds another layer to this evolving picture. And with every new observation, a deeper realization forms. The universe is not a simple machine operating under fixed rules. It is a dynamic system of interactions, constantly reshaping itself through gravity, energy, and time. As Webb continues to collect ancient light from the farthest reaches of space, it is not merely observing distant objects, it is reconstructing the history of existence itself. Each photon carries information from a time long before Earth existed. Each signal is a fragment of cosmic memory. And when these fragments are combined, they reveal something extraordinary. The universe is still unfolding. Still evolving. Still rewriting its own story. And somewhere in that vast darkness, the same forces that created galaxies, stars, and black holes continue their silent work, shaping a cosmos far more complex, and far more beautiful, than anything previously imagined.